Okay, so last topic that we're going to go over in chemistry is the one that involves us doing a little bit of math. Okay, it's not super difficult math, but it does involve us doing a little bit of math. So from here forward, you require a scientific calculator. Okay, if you already have one of those big graphing calculators, great. Okay, that will work just fine. Okay, it'll do everything you absolutely need it to do. But so will that, and it costs a heck of a lot less than the big graphing calculator thing. Okay, so if you you can go to the Wally World and you can get one of these. I think they even sell them like Staples, places like that, and they're like less than $15. Okay, so they're a very economical choice, and will do everything that you need. Okay, if that's a consideration. Okay. All right. So we're going to talk about the mole and the mole equation. So, are atoms really small? They are, right? I mean, that was the first point. They're tiny, indivisible particles. Okay. So we can't see them. We can't count them. Okay. Because obviously we can't see them, but also even a tiny amount of anything would have more atoms in it than you could probably count if you counted every day for the rest of your life. Okay, so it's not practical to count atoms. So what we do instead is we use the mole. Okay, the mole is a representative number. Okay, and it works the same way that a dozen does. If I tell you I have a dozen eggs, how many do I have? 12. Dozen always means 12. Okay? A mole always means this many. .02 times 10 to the 23. That's a big number, by the way. Like, huge. Okay? It's 602 with another 21 zeros behind it. Okay, so it's a huge, unfathomably large number. Okay, but a mole always means that many. It doesn't matter whether I have a mole of sodium or a mole of oxygen, okay, or a mole of iron. If I have a mole, that's how many I have. In the same way that it doesn't matter if I have a dozen eggs, a dozen donuts, I have 12. Okay, a mole is always that number. Does that sort of make sense? Okay. Now, you might wonder, how did they arrive at this number? Okay, like a dozen is easy, we count to 12. Okay, that's fine. Okay, why would we pick that number? Like, what a random number to pick, right? Okay, and it's because we didn't pick it. It was calculated. All right? The person who came up with the idea of having a representative number, like 12 for a dozen, okay, used hydrogen to come up with this number, because hydrogen is the simplest atom. It has one proton and how many electrons? It has one proton, it has one electron, right? Okay, it has no neutrons. It's a very, very simple atom. Okay, so what they did is they said, I'm going to figure out how many hydrogen atoms would be in 1 gram of hydrogen. Okay, that is why hydrogen's atomic number is basically 1 gram. Okay, so what they did is they did the math and figured out how many atoms would be in 1 gram of hydrogen, and it was that many. And then they just said, okay, that's the number I'm going to use for everything. That is the atomic mass of every single element. If I have 1 mole of sodium, it will have a mass of 22.99 grams. If I have 1 mole of beryllium, it will have a mass of 9.01 grams. Okay, we're talking about the same number of particles, but because the atoms are different, bigger, okay, they have different atomic masses. Pretty okay with that? Okay. So that number that you see on there is the molar mass, or atomic mass, of each element. Okay? If I have 6.02 times 10 to the 23 titanium atoms, I will have 47.87 grams of titanium. Okay? Everybody all right with that idea? All right, so what we're going to be looking at today is that number as well as the mole equation. Okay, the mole equation is pretty straightforward. Okay, n equals little m over big M. That is the mole equation. Okay. So we'll be using that to do a few calculations. We're going to have to do a little bit of algebra. That's okay. Okay. We're going to go over the rules of algebra. Okay. Teach you how to manipulate it, all that kind of good stuff. Okay. So second point here says we want to understand the relationship between moles, mass, and molar mass. Those are the three parts of the mole equation. Okay. So moles is n, mass is little m, and molar mass is capital M. Okay, so there's lots of different ways to measure how much of something we have. Okay, we can use mass. That would be in grams or kilograms or something like that. Okay, we can use volume. That would be in liters or cubic centimeters, okay, or something like that. Okay, or we could use like tons or molecules or whatever. Okay, but as we've already established, knowing the exact number of molecules by counting them is impossible. Okay? But sometimes it's still good to have an idea of how many molecules we might have. That's where the mole equation comes into play. It can help us to calculate that. Okay? All right, so we can't possibly count particles, so we use this representative number called the mole. Okay? And because we're very, very busy, we will abbreviate it mole by cutting off the E and saving us 25% of the time it would take to write the whole word. But we're busy. We're a busy society. Okay? We have an abbreviation for at. You have to be. We're just that busy. Okay? All right. So a mole, as I said before, works the same way as a dozen does. A mole is always this many particles. Okay? That is Avogadro's number. Avogadro is the person who came up with the idea. Why he called it the mole will become evident when you see his picture. Okay? At least that's what I think. I don't know why he looks like a mole. Okay? He's got like no shoulders and yeah, he's strange looking. Okay? All right, so you'll need to know his name, okay? You'll need to know that this is Avogadro's number, okay? And it is the number of particles in one mole. Now, something to note. I keep using the word particles. There are this many particles in a mole. I don't say atoms. Why? If I had this, the smallest particle of sodium chloride isn't an atom, it's a molecule. Okay? Both atoms and molecules are particles. That's why I'm using the word particle. Okay? We can use this mole equation and the mole number with atoms or with molecules. Okay? So we use the word particle. The smallest particle of whatever you're dealing with is what we're going to use. Okay? If it's a compound, the smallest particle is a molecule. If it's an element, the smallest particle is an atom. Okay? All right. Questions so far? Okay, so all we really need to get out of this slide is Avogadro's number, okay, number of particles in a mole, and that a mole is used to measure the amount of something. Okay, so if I said I had 2 moles of something, okay, you would know how many I had. You would have 2 times that number. Okay, Now, the mass of 1 mole of a particular substance is what we call the molar mass, the capital M part of the mole equation. Okay? For elements, that number is given to us on the periodic table. Okay? If I want to know the molar mass of zinc, I just look right here in box number 30, and I see that the mass of 1 mole of zinc is 65.41. All right? What if I wanted to know the mass, the molar mass of water? Can I look on the periodic table and find that? No, because the periodic table only has the elements on it. Okay? Do I know what water looks like? Yeah, of course, it's a clear, odorless liquid, but it also looks like that. Okay? How many hydrogens are in there? Okay, what's the mass of 1 mole of hydrogen? This number, right? The atomic mass. That's for 1 hydrogen. How many hydrogens do I have? 2. Okay. So if I want to calculate the mass of 1 mole of hydrogen, I just use the individual parts of it. I can look those parts up on the periodic table. Okay? So I would say, all right, hydrogen is 1.01, and there are 2 of them. And then I would add that to the mass of oxygen. I only have 1 oxygen in this compound. Oxygen's atomic mass is 16. Okay, so that would be 18.02 grams per mole. It's the mass of 1 mole, so it's grams per mole. Okay, calculate for me the molar mass of cesium sulfide. Okay, so if we're going to do this one here, okay, we got to look up the molar mass for cesium. Okay, so the molar mass or atomic mass for cesium is 132.91. All right, so I'll write that here, 132.91. How many cesiums do I have? Okay, so I got to multiply that number by 2. Okay, and then I have to add on to that the sulfur. Okay, so I'll go over to my periodic table, and I see that sulfur is 32.07. How many sulfurs do I have?
One.
Just one, yeah, so 32.07, okay, and I put those two together. I should have started my calculator. What does that come out to, you guys?
297.89.
297.89. What are my units?
Per mole.
Grams per mole. Okay, how important are units, guys? Very. Okay, in science going forward, and it doesn't matter which science you go forward in, okay, this course, bio, chem, physics, if you don't put units on an answer, it's wrong. Even if the number is right. Because I don't know whether you mean 297.89 grams per mole, 297.89 elephants, old ladies with walkers, I don't know. If you don't put units on it, the number is meaningless. Okay, so you've got to put units on your answers. Okay, get in the habit of it. Okay, well, let's try one that's maybe a little trickier. Let's try. Got to do a little more multiplying once the brackets get involved, right? Okay, let's have a look at this one. So one of the things you have to be able to do when you're calculating molar mass is interpret how many of each element there are in a particular compound. How many beryllium in this compound?
One.
Just one. Okay, so if I'm calculating this, I would put in just one beryllium, 9.01. How many nitrogens in this compound? Two. Okay, because nitrate is in brackets and it says there are two of them. So I would add on to that 14.01 times 2. How many oxygens? 6. 3 times 2 is 6. Okay, so I'm going to have to add on to that 16 times 6. Okay, so we'll have 9.01 plus 14.01 times 2 plus 16 times 6. All right, so we are looking at 133.03 grams per mole.
Could you also treat a polyatomic ion like it's a compound in itself, where you just like do how much nitrogen would be and oxygen and just add those together and then times it?
Yeah, so you went 14.01 plus 16 times 3 and then multiply that by 2? Yeah.
Okay.
Order of operations works just fine there. Yeah.
I got a different answer for you.
Because you multiplied the beryllium by 2. There's only one beryllium there. Okay, everybody with me on that? Okay. Calculate for me the molar masses of those 5 compounds there. All right, so our first one here, we got sodium chloride. How many sodiums in here? Just one. Okay, so we're going to go 22.99. Okay, and then we're going to add to that 1 chlorine, 35.45. Okay, so put those together. Come on. 22.99 plus 35.45, 58.44. What are my units? Grams per mole, right? Because this is the mass of 1 mole of sodium chloride, grams per mole. All right, looking at the second one. How many iron? Just one, so 55.85. Always get it backwards. Okay, 55.85 plus how many bromine? 3. Okay, so 79.90, I believe, times 3. Okay, so 55.85 plus 79.9 times 3. So we should be looking at 295.55 grams per mole. Okay, keep going, guys. If you're having trouble, let me know. I'll give you a hand. Okay, so for number 3, how many phosphorus do I have?
2.
2. Okay, so 30 30.97
Yes.
times 2, okay, plus how many oxygens?
5.
5. Okay, so 16 times 5. All right, so we punch that in, 30.97 times 2 plus 16 times 5. All right, we're looking at 141.94 grams per mole. Okay, anybody want more time on number 4? Okay, so let's look at number 4. When you have polyatomic ions and you've got the brackets, you got to do a little bit more thinking. Okay, it's not difficult math, but you have to kind of foil it through. Okay, since this is all in brackets, how many nitrogens do I have? 2. All right, so I'm going to start out with 14.01 times 2 plus how many hydrogens? 8. Okay, so I'm just going to write 8.08, right? 1.01 times 8 plus how many sulfur? Just 1, yeah, so plus 32.07, 7 or 6? 7. Okay, and then how many oxygens? 4, plus 16 times 4. So yeah, if you've got an ionic compound that's got 2 polyatomic ions, it's going to take you a little longer, okay, to calculate the molar mass, but the process is still the same. All right, so we'll have our 14.01 times 2 plus our 8 hydrogens, okay, plus our sulfur, plus our oxygens. 132.17 grams per mole. Okay, anybody want more time on 5? Okay, let's look at number 5 as well then. All right, so we got scandium carbonates. How many scandium do we have? 2. All right, I don't know what that's for scandium. 44.96. Okay, 44.96 times 2 plus how many carbons? 3. Okay, so 12.01 times 3 plus how many oxygens?
6.
9. 3 times 3 is 9. Yes, 16 times 9. All right, so 44.96 times 2 plus 12.01 times 3 plus, okay, 12.01 times 3 plus 16 times 9. All right, 269.95. Per mole. Okay? Everybody all right with that? Okay, now, the reason we use moles is because if we're communicating a balanced chemical reaction, like this one, okay? This is a reaction used to make ammonia, which is an ingredient in fertilizer, okay? We would combine, there's like basically 3 different ways to read this equation. I could read it literally and say 1 molecule of nitrogen is reacting with 3 molecules of hydrogen to produce 2 molecules of nitrogen trihydride. Would I even be able to observe a reaction between that small amount of stuff? It's tiny. Okay, I can't see individual atoms. I'd never be able to even observe that reaction. Okay, but it literally means that. But it could also mean 1 mole of this stuff. Would that be a larger amount? It would be. It would be 28.02 grams of this stuff. Okay, that would be an observable amount. Okay, so 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas, also an observable amount. We'd be looking at 6.06 grams of that, okay? And that would produce, okay, 28 or 30 something, okay, grams of nitrogen trihydride. That would be an observable amount. So when we balance an equation, what we're really saying is it's this many moles plus this many moles gives me, well, the same amount of moles on the other side, okay? Everybody all right with that? Okay, like when we balance an equation, that's why we do it. Okay, all right. So we could say we mean particles, we could say we mean moles, that's Avogadro. right? Like he's got these like sunken eyes like a mole. And he's got, and I'm sure it's just the cut of his suit, but it looks like he has no shoulders. Okay? Moles burrow through the ground. They have very small shoulders. Okay, so we talked about the ratios part there. Okay, now. Okay, well, let's talk about the mole equation here. Okay, so our mole equation sets up as n equals little m over big M. Okay, where n is the number of moles. Okay, little m is the mass, always in grams. And then the capital M is the molar mass, the thing we were just learning how to calculate a few minutes ago. That is always in grams per mole. Okay, so the mole equation is n, number of moles, equals mass divided by molar mass. Okay. Now, at this point, okay, this formula sets up to calculate the number of moles. We may need it to calculate things other than just the number of moles. In that case, then, we'll have to manipulate it. We'll have to do a little bit of algebra, okay, to start moving things around within the equation. So, you may have been taught something by a well-meaning but misguided person. Okay? You may have been taught that you can use one of these to calculate stuff or to move equations around and manipulate them. That person was mistaken. Okay? Those don't work. I mean, they work for this formula, yes, but they're a crutch. And you'll never walk by yourself again if you lean on a crutch for the rest of your life. So, triangles are out. We're going to learn to do algebra here. Okay? Reason for that? Later on in this course, you're going to have to manipulate formulas like this one. Got a triangle for that? No. Maybe a rhombus or a trapezoid or something? No! Okay, shapes don't work. Shapes are dumb. Okay? They don't work. Similarly, here's another one you're going to have to use later on in this course. E equals 1/2 times mv squared. I don't know where you put a square inside a triangle. Okay? I don't think that's going to work either. Okay? Or maybe you take physics 20. I don't know where you put a triangle for that one either. Okay? Here's the good news. Triangles not only suck, but they're useless. And the rules of algebra are easy. Okay? All you have to do is learn the 3 rules of algebra. And you can be like me, someone who's not good at math, but can do algebra no problem. Okay? I'm not a terribly strong math person, but I teach physics. Because I can do algebra, and that's all I need to be able to do. These 3 rules that I'm going to teach you today got me through university physics. I don't mean to brag, but I did really good. Okay, in university physics, only knowing how to manipulate equations. Okay, you go into calculus, that's something entirely different. You're on your own with that. Okay, but if you're just doing linear stuff, okay, these 3 rules of algebra are good enough to get you through anything. Okay, so if I wanted to manipulate this formula here to solve for little m, what would I have to do with big M?
Is it?
Yeah, I'd have to multiply it. Right now, I'm dividing by big M. Would you agree? I have little m divided by big M. Okay? The first rule of algebra is that if you want to move something, you move it by doing the opposite of what is being done currently. Right now, I'm dividing by m. So if I wanted to move big M over to the other side, I would multiply both sides by it. Okay? So in this case, I would go and multiply this side. I have an m on the top, an m on the bottom, and they would cancel. Okay, everybody with me there? Now, the second rule of algebra is what we call the golden rule of algebra. What you do to one side must be done to the other. I multiplied that side by m. Now I multiplied this side by m. And lo and behold, I moved m over to the other side. Okay? Everybody okay with that? All right. You'll use the first two rules a lot. There is a third rule. It doesn't really apply to this formula, but we're going to go over it anyway. Okay? All right, well, let's have you guys copy down these 3 rules of algebra, and then we'll talk about how they work. Okay, give you a minute to copy those down, and then we'll talk about how they work. So, let's do this. There are 4 ways I can ask you a mole equation problem. What we're going to do for the next few days is work on those 4 ways. Start of each class, I will go over one example of each. So by the time we're done, you will have 4 different examples of each of the 4 ways I can ask a mole equation problem solved in your notes. Okay, so lots of examples, lots of practice, and you guys won't have any trouble with this stuff. So this is type 1. Write this one down, and then we'll walk through how it works. So anytime you're doing problem solving, the first thing you want to do is what we call writing out your givens. Okay? Write out the things the question tells you. Right? In this question, they're asking how many moles. So I'm being asked to calculate number of moles, which is which letter in that equation? N. Yeah. Number of moles is N. Okay? I know it's confusing. Chemists are mean. Okay? They made a 3-variable formula, and it only has 2 letters in it, and they're the 2 letters in the alphabet that sound the most alike. N is little m over big M. Right? Like, you couldn't use A and B? Like, come on. Right? So, we are looking for N. We're looking for the number of moles. Okay? And then they tell me that the stuff I'm talking about is calcium chloride. What can that help me find? Molar mass. Yeah, it can help me find big M. All right? Anytime I'm given the material, which I kind of have to be given, okay, I can calculate big M. So go to my periodic table. Okay, I know it's CaCl2, so that's going to be 40.08. That's my 1 calcium, plus 2 chlorines, so 35.45 times 2. That should be, I shouldn't do mental math, but I think it's that number. We'll just punch it in to be sure. Okay, so 1 calcium plus 2 chlorines. Okay, 110.98 grams per mole. Okay, did they give me one more thing?
The grams?
Yeah, they gave me the grams. So that's little m. Okay, so that would be 90 grams. All right, doing this, that's worth a mark. Okay, so I give you a quiz on mole equation. You do that, you got 1. Okay, the next thing you get a mark for is going, hey, this is a mole equation problem. And showing me what formula you would use. That's pretty much a gimme mark because it's the only formula in this whole unit. Okay? Do I need to do any algebra here? I'm looking for n. Is it already set up to solve for that? Okay, so I don't have to do any algebra. I just have to put the numbers in the formula. Okay, so that would be 90 grams. That was what n was. Divided by 110.98. That's what big n was in grams per mole. Okay, you wouldn't get an additional mark for this step on a question like this because you didn't have to do any algebra to get to here. Okay, but you would get a mark for your final answer. Okay, so we would go 90 divided by 110.98. All right. Is it okay that we got a decimal? Yeah, we have less than a mole, right? 1 mole is 110 grams. We only had 90, so it makes sense that it should be less than 1.81. Oh, not grams. What are my units? It's moles, yeah. Okay, so 0.81 mole. Okay, that would be your third and final mark. And we'll say 2 decimal places on your final answer is good enough. Okay, everybody all right with that one? Type 1 are the easiest. You don't have to do any algebra. You basically just plug the numbers into your calculator and it spits out the answer for you. Okay? All right. Let's have you write this one down. This is a type 2 problem. So same thing. We want to write down our givens first. Okay? Starts out with what is the mass? What am I looking for here? Okay. N, little m or big M? Little m. Big M is molar mass, right? Okay, so I'm looking for little m here, okay? What is the mass of 4.5 moles? What did they give me there?
Moles.
Moles, which is N. Okay, of magnesium bromide. Okay, they gave it to me in words. I'm gonna need it in formula form, so I can calculate the molar mass. Here's another place where being able to do the drop and swap and get our formulas is really important. Okay, so I'm looking for big M. I know the material is magnesium bromide. This is a 2 plus, that's a 1 minus. So I'm looking at MgBr2. Okay, so I'm gonna have 29.31. 24.31. Okay, 24.31. There's only 1 magnesium here, so that's all I need there. Plus 2 bromines, so 79.9 times 2. All right, 184.11 grams per mole. Okay, I have N, and I have big M, and I'm looking for little m. 1 mark for that. Okay, is this the formula I would use? It's the one I'd start with, but I do have to manipulate it, right? I gotta turn it around. Okay, so I'd still get a mark for that, but now I need to isolate little m. I wanna leave it there, I need to move big M. What do I do with it? Yeah, multiply it over to the other side. Okay, so I multiply this side by big M, it'll cancel, big M comes over here. All right, so you would get a mark for your algebra. Okay, so I would show your work as you go along. Okay, so big M times N equals little m, and then show me your numbers plugged in. Okay, so we would have 184.11 times 4.5. Okay, this was grams per mole, and this was moles. Okay, so the moles are going to cancel, okay, and we'll be left with grams. Okay, so this would be your third mark right here, okay, showing that algebra. And then your fourth mark would be for your answer. So that 184.11 times 4.5. Okay, 828.50. $828.50 what? Grams. Okay, so that would be your fourth mark. Okay, I want to stress how important it is to show your work. If you only write down a final answer, and it's right, I would still give you full marks. But if all you write down is a final answer, and it's wrong, what can I give you?
Zero.
Right. I can give you nothing because you've written nothing but a number that's meaningless. Okay? So, show your work. The method is important. Your work is important. Show it all. Okay? Because I've had cases in the past where people are like, I don't need to show my work. I'm so smart. S-M-R-T. Okay? And they're not. Okay? They mess up on their calculator, it's in the wrong mode, and instead of getting 16 marks on 4 questions, they get none. When they probably knew very well how to do it, but were inept in adding things in their calculator. Okay? I don't want that for you. I want you to show me what you can do. Okay? So show me all the parts of your work so I can give you marks along the way. Because it happens sometimes. You know, we just get clumsy on the calculator and we misenter a number and we get the answer wrong. But if you have the work right all the way along, you only lose 1 mark for not being good at entering numbers in your calculator. Okay? All right, so that's types 1 and 2. They just involve the mole equation. Types 3 and 4 are going to have an extra step. That extra step is going to involve Avogadro's number, that 6.02 times 10 to the 23, okay? The number of particles in 1 mole. Okay, so they'll have an extra step. That extra step will be either multiplying by Avogadro's number or dividing by Avogadro's number. Okay, and as we talk about it, it'll be very obvious which one you'll want to do. All right, I'll write down this type 3 question and then we'll go through it here in a minute. All right, this one wants to know how many molecules there are. Okay, is that part of n equals little m over big M? It's not, right? N is number of moles, little m is mass, big M is molar mass. Number of molecules is not in that formula. We're still going to need to use that formula, but this is where that extra step involving Avogadro's number will come into play. So, we still need to write down our givens, okay? We're looking for the number of molecules, so I'm just, there we go, okay. I'm just going to write number of molecules. That means number, by the way. I'm not writing hashtag molecules, okay? Number of molecules, okay? So that's what I'm looking for. Okay, are in 600 grams. What did they tell me? Little n, yeah, they told me mass. Okay. Okay, and they tell me it's silver nitrate. So if I put that in formula form, it can help me get big M. Okay, so big M, okay, silver is Ag, that's a +1, nitrate, NO3, that's a -1, so that compound's okay the way I wrote it. I just have to calculate its molar mass. Okay, silver's 107.87. Okay, plus, how many nitrogens? Just 1, yep, plus 14.01, plus, how many oxygens? 3. Okay, so 107.87 plus 14.01 plus 16 times 3, 169.88. Okay. So I've got little m and I've got big M. What can I calculate with those two numbers? N, yeah. And that's all I can do right now. I know that's not what the question wants, but that's as far as I can go with what I have right now. Okay, so that's what I'm going to do. I'm going to say, this is all I have, little m and big M. All I can calculate with those is the number of moles. Okay, so I'll calculate that. I have 600 grams of silver nitrate. Okay. So if I punch that into my calculator, I'll get the number of moles. Okay, there are 3.53 moles. I'm going to keep all the decimals in my calculator, as you should. Okay, we don't round ever until our final answer. We keep everything until we're at our final answer in all sciences. Okay, so I'm going to keep those. I'm just going to write 3.53 for now. Okay. So I said this question was going to involve Avogadro's number. What does Avogadro's number tell us again? How much in 1 mole, right? This is the number of silver nitrate molecules in 1 mole of silver nitrate. How many moles of silver nitrate do I have? 3.53. That's what I just calculated. Okay? I just calculated how many moles of silver nitrate I have. And I know that in each one of these 3.53 moles, there are this many molecules. So to get the number of molecules, what should I do with those two numbers? Okay, let me ask you this. I'll ask it a different way. I have 3 dozen donuts. How many donuts do I have? 3 times 12, which is how many? 36. Okay, now let me ask you again. I have 3.53 moles of silver nitrate. This is the number of molecules in 1 mole. What should I do with those two numbers? Times. Just like you did with the donuts question. Okay, you took 3, the number of dozen, and you multiplied it by how many are in a dozen. You went 3 times 12. The same is true here. This is how many are in a mole. This is like 12. Okay, multiply it by this. Here's how you can ask yourself this question. If I multiply numbers together, I get bigger numbers, right? Okay, is the number of molecules going to be a big number? Then I should multiply to get it. If I'm given the number of molecules, I'm going to want to go to a smaller number. So I would want to divide. You're only ever going to multiply or divide by Avogadro's number. Okay? The way you decide which one you're doing, do I want a big number or a little number? Okay? If I want a big number, like number of molecules, I'd multiply by Avogadro's number. If I want a small number, like mass, I would divide. Okay? Making some sense? You just have to ask yourself a mathematical reasoning question. Okay, so I'm going to multiply these two numbers together. Okay, to get the number of molecules, okay, I would multiply n by Avogadro's number. Okay, so that's going to be 3.53 times 6.02 times 10 to the 23. Now at this point you might be like, how the heck do I put that number in my calculator? Good question. I'm going to show you. Okay? If you have one of these, okay, so any type of graphing calculator, this is how you do it. You take your 3.53 and then you multiply and then you put in brackets. Okay? Avogadro's number always has to be enclosed in brackets when you use it. Okay, so I'm going to go bracket 6.02. And then to get the times 10, I'm going to hit the second function button. So right here at the top. And I'm going to hit the comma. See above the comma, it's got 2 capital letter E's. Okay, puts in an E here. That E means times 10. And the next number you're going to put in is the power of 10, which is 23. Okay, so you go 6.02 E 23. Close the brackets. Okay, now if you don't have a graphing calculator, you will have one or the other of these buttons. You will have an EE button, like what I just used, or you will have one of these. An EXP button. Okay, they serve the same function. So you would go brackets 6.02 EXP 23, close the brackets. Okay, if you're not sure, look in your calculator, can't find it, call me over, okay, and I'll find it for you. All right, so when I punch that number in and hit enter, I get a huge number. Good, I should get a huge number. There should be a lot of molecules in 3.53 moles of silver nitrate. Okay, so what this number here is 2.13 times 10 to the 24. Okay, that's all I have to write. That's my final answer. Okay, 2.13 times 10 to the 24 molecules. Still gotta add units. Okay, anybody got a calculator they need me to have a look at? Sorry guys, you may also have, sorry, I'm seeing this one more often now as well. You may have this button, times 10x. Okay, if your calculator has that button on it, okay, that's what you use. Cassie uses that. Okay, can we move on to type 4? I'd like to get the type 4 done before the bell goes here real quick. Okay, write down this type 4 question. We'll go through it real fast, and then we'll do some more tomorrow. All right, so in a type 4 question, they give you the number of molecules, and they want you to find the mass. Okay, so one of your givens will be number of molecules. Okay, in this case, 1.54 times 10 to the 25 molecules. Okay, and it is of diphosphorus tetraiodide. Okay, so getting the molar mass of that is going to be 30.97 times 2 plus 176.9. 126. That was close. Times 4. Okay, and they want me to calculate mass, which is little m. Okay. According to the mole equation, to get little m, I need big M, which I have, and I need n. I need the number of moles. okay? I don't have that right now. What I have is the number of molecules and Avogadro's number. Did I mention you don't have to memorize that number? It's on your formula sheet. Okay, if you flip over your periodic table, Avogadro's number is on the back of that. Okay? It's not a number you have to memorize, you always have it. Okay, so Avogadro's number is the number of molecules in 1 mole. I know how many molecules I have. Number of moles. Big number or small number? Small number. So, should I multiply by Avogadro's number or divide by Avogadro's number? I should divide. Okay, so to get the number of moles, I'm going to take the 1.54 times 10 to the 25, and I'm going to divide it by 6.02 times 10 to the 23. Okay, now in your calculator, that's going to be a lot of brackets. Okay, so 1.54 E25, okay, divided by 6.02 E23. Good, I got a smaller number, 25.58 moles. Okay, everybody with me so far? Now that I have N and big M, can I get mass? Yeah, I just used the mole equation, right? Now I've got this number and that number. I should be able to calculate N. Okay, that's all the time we have today, guys. I don't know if the bells are still working or not, but it's going to go off here in a minute. So, tomorrow, quiz is on predicting. Oh, which quizzes were you supposed to do? Sorry. Supposed to check that. Okay, practice quizzes you should do, guys, are 12 and 13. Okay, do practice quizzes 12 and 13 for this week. You're welcome. No, because we already went through it. Yeah.